Okay, so let's start the series on inequalities. This will be a 4-part video, and specifically, we will start with linear inequalities, the most basic one. So let's begin with this first item. So in here, we have a simple inequality, and the trick in inequalities is simply just like how we do it in equations. We isolate the variable x on one side, and then the constants on the other side. So in this case, like how we do it in equations, we can simply move this to the other side so that the two x's there will be together. And again, when we move across this time inequality, it is important to note that we must change the sign of that certain thing that we same for -2, we move it to the other side, and when we do that, it will become positive. What I mean by that is, let's fix this one first. Okay, so again, what we will do here is technically we will be adding x's to the both sides and then adding 2 to the both sides. So on the left, we will be having 2x, and then on the right, we will be obtaining 6. And then what do we do next here? For this next one, since again our goal is to get x or just obtain x out here, then basically we must divide both sides out here. So dividing both sides, that will give us x less than 3. And it's important to note here that in inequalities, since we are just adding stuff out here, so the inequality won't change. And since we are dividing or technically multiplying a positive value, the inequality will also not change. So by that, I mean, we can conclude that this out here is the answer for the problem. Or in interval notation, this is given by x from -infinity, since we're dealing with less than, until 3. Let's move on to the second one. Okay, so for this next one, so we have here two technically rational expressions out here, but we can still view them as linear since these things are just constants. So how can we view this as linear? Well, we can just multiply both sides by 4, and that would omit the denominator. So what I mean by that is, so again, multiplying for both sides. So just take note that I prefer this symbol rather than the multiplication symbol since we are dealing with variables x out here. So multiplying for both sides, that will give us 2x minus 3 greater than or equal to, for this part, when we multiply this by 4, the 2's will cancel out and we'll be left with a 2, multiply that to 7x, and that will give us 14x. And then from here, we just do the same trick. We do our best to isolate 14, or rather x on one side. So technically, we need to move this to the other side and this one to the other side. To do that, what we will do here is we will subtract 14x both sides and then add 3 both sides. So for this left side, adding 3, subtracting -14x will give us -12x. And then this is greater than or equal. For this right side, if we subtract 14x and add 3, we will obtain 3. And then last thing to do is to obtain x here, we must divide both sides by its coefficient, which is -12. So dividing -12 out here, take note that when we divide -12 out here, this is a negative value, which means that this sign must flip because that's how inequalities work. On this left side, we will obtain x, and this is less than or equal to 3 divided by -12. That will give you -1/4. Or in interval notation, this is given by x in the interval from -infinity to -1/4 with a closed bracket, since this time we are dealing with less than or equal to. And these two are basically the answer for this. Okay, let's move on to the third item. Okay, so this time when we have an inequality that is bounded by 2 inequalities. So what I mean by that is one expression bounded by one on the left side and one on the right. And the trick here is that if possible, we do things simultaneously. What I mean by that is the manipulations that we do out here, we do here as well, and we do here as well, all together. So the first thing that we can do here is we can eliminate this thing out here. And to do that, all we need to do is to add 4 both sides, or in all of the parts of the inequality. So by doing that, on this left one, we will obtain 9 less than or equal to on this middle one. This one will be eliminated, so we will get 3x. And then on the last side, we will obtain 11. And then this time, since our goal is to isolate x, all that is left to do is to divide 3 in all of the sides. So dividing 3 in all of the parts, that will give us 3 less than or equal to x less than or equal to 11 over 3. There you go. And that's basically what we want out here, since observe that x is already isolated, just has a different look this time since we have the 2 inequalities bounding it. So this one is the answer, or in interval notation, a more nice looking notation. This is basically 3 to 11 over 3 with both closed brackets, since we're dealing with less than or equal to in this case. So that's the answer for this problem. Finally, let's go on to our final item. Okay, so for this item, you might try to think that we can apply the same trick on the third item, but it doesn't really apply here, since observe that we have x's in this bounds out here, and that they both have different coefficients, so we can't really eliminate them. So to deal with this, another trick that can be done in inequalities is to split the given inequality into 2. What I mean by that is we split it into, this one will be the first part and this one will be the second. So let's put a mark out there. So it's like this one will be the first inequality, and then this one out here will be the second inequality. So doing that one, we will have here 3x greater than or equal to 2x minus 1 and 3x less than or equal to 4x plus 1. So now that we have this, it is important to first note that we use an and here instead of the usual or, since what we will do is upon obtaining a solution out here, we will get their intersection. Or it's usually denoted by this symbol. Just something that is important to know. So with that in mind, let's solve the 2 inequalities. So in solving this, the manipulations that we do here doesn't necessarily mean that we do as well here. So let's first deal with this first one. So for the first one, to isolate x on one side, all we need to do is to move 2x out here to the left. Or essentially, what we will be doing is we will be subtracting 2x both sides. So that will give us x greater than or equal to negative 1. And on the other side, what we do instead is we move 4x to the left side. It's the same as saying that we will be subtracting 4x both sides, and that will give us negative x less than or equal to 1. Finally, since we want x to be left out here and we still have a negative, we just multiply both sides by negative 1. Multiplying negative 1 out here, take note again, when we multiply a negative value, we basically flip the sign. So we'll have here x to be greater than or equal to negative 1. So are these two the final answer? Not yet, since we still need to get their intersection. But fortunately, observe that these two are essentially the same thing. So getting their intersection will just give this. So what I mean by that is the solution set for this problem is given by x greater than or equal to negative 1, or again in interval notation is given by x in the interval negative 1 to positive infinity, since we are dealing with greater than or equal to. So that is basically it. So just a brief recap of what we did out here. So we dealt with linear inequalities, and we had this for problems out here. Oops, I forgot this one. There you go. So in the next video, we will be having higher degree inequalities. So let's change. So that is it for now. If you have any questions or concerns or criticisms about this, by the way, I will be uploading a Google form in the description down below or comment down below so that you can give feedback on these types of video, because I also want to improve the content that I provide to you all, like any suggestions of topics, any suggestions of format, any suggestions of length of video or whatever. So yeah, that is basically it. If you don't have any concerns, criticisms or questions, then that's it for this video.